Hello, welcome back to our series on Kubernetes for beginners. If you have been following this series by now, you should have a good understanding of basic Kubernetes concepts. You must be well aware of ports, you know what are the replica sets, you know how deployments can work, and you have likely worked with labels and selectors. That's a solid foundation and a big shout out to yourself. But let's take it further. Now consider two scenarios. First, imagine you had deployed a front-end application as a pod. Now, to allow end users to access the application, you need to expose the pod to the external world. By default, pods are isolated inside the cluster, and external users cannot directly communicate with this. Second scenario, now let's say your front-end application needs to communicate with the backend ports. Well, you can't directly communicate with the IP address, and I'll tell you why. Then how does communication works? Well, the answer is services. This is why understanding Kubernetes services are crucial, and in this video we will dive deep into how services work, why they are essential, and the various types of services available. Whether you are a beginner or an advanced user, this video might have something valuable for you. Okay, let's start with the why. In Kubernetes, pods are created and deleted constantly because of scaling, updates, or failures. Each pod has its own unique IP address, and this IP changes constantly after pods are restarted. For example, you update the image name in your deployment. Now all ports will be deleted and new ones will be created with new IP address. So you can't rely on IP address of ports for communication. You need something which will have a constant IP address, and that's where services comes in. Services ensures traffic continuously to flow seamlessly to the new pod. A service in Kubernetes acts like a stable bridge between a set of pods and external and internal traffic. It provides a consistent IP address and DNS name, so you don't have to worry about the dynamic nature of pods. So how do you manage communication efficiently? Well, Kubernetes services solve this problem by grouping pods and providing a single stable interface for accessing them. For instance, you can create a service for your front-end pods, which will give you a single point of contact to all the front-end pods. All requests to the service will be distributed among the group front-end pods. Even as pods are added or removed, this service ensures that the communication is unaffected. Let's now dive into different types of services Kubernetes offers. There are four core service types: ClusterIP, NodePort, LoadBalancer, and external name. But we also have a special type called ingress service. We will go through each one in detail. ClusterIP is the default service type in Kubernetes. It provides an internal IP address that is accessible only from within the cluster. This type is perfect for services that needs to communicate exclusively within the cluster. Let's have a basic example of cluster IP service using YAML. So it will have an API version and kind. Let's give it a name and jump to the specification section. It will have selector that help us identify which ports you want to group. So let's say we will group the backend ports. So all the ports with label as app is backend will be grouped together by this service. The type is cluster IP. In fact, cluster IP is the default type. So even if you don't specify it, it will automatically assume to be a cluster IP service. Under ports, we have a target port and a port. Now, the target port is the port where the ports where label backend is exposed, which in this case is 8080. Port is where the service is exposed, which is 8080. By creating this service, we ensure that our backend ports are reachable through a single IP, even if individual ports are restarted or scaled up or down. Once you create the service, Kubernetes assigns a virtual IP address, and any requests to this IP are routed by a kube proxy to one of the selected backend ports. This setup ensures reliable internal communication while hiding the complexity of port restart or dynamic scaling from the rest of your application. Okay, so let's open terminal and create this service by simply using the command kubectl apply -f cluster service.yaml. Now let's run a command kubectl get services or simply svc, and we can see our service is created. Our service has name that we assigned while creating service definition, and the type is ClusterIP. Also, we can see an IP address has been assigned to it. This is a private cluster IP address. So we can see external IP column does not have any value, as cluster IP cannot be accessed from external network. It also have port number that we define. So that means that this service is accessible at port 8080. Now let's try to access this IP from outside the cluster. We can do curl, then IP address and the port number, and we can see nothing is happening. Well, let's try to connect this IP address from an object within cluster. So let's get list of ports and execute under one of this port. So simply type kubectl exec it, the port name and the bash command. Now let's do curl and the IP address and the port number. We can now see that the connection is established and we can communicate. As we can see, this curl command has returned us with some data. We can also access the service not just with the IP address but with the name of service as well. So let's type curl and the service name, that is cluster service, and the port number, and see we got the results. Now this IP will remain constant unless you delete a service. However, we no longer need port's IP address to connect within the cluster. But how can we access application deployed on the ports from our browser? There comes the NodePort service. A NodePort exposes your application on each node's IP address at a static port. So we can say like every node will have an IP address, and it will just open up one port so that we can communicate with it, making it accessible from outside the cluster. It maps an external port on the node called as the NodePort to the service's internal port, which then routes traffic to the relevant ports. Let's look into the YAML file. Like a typical YAML file, it will also have an API version, kind, and the metadata, where we give the name to the service, say NodePort service. Okay, the type is NodePort and we have to specify it. Remember, in case of cluster IP, it was not required as cluster IP is the default. But for other service types, we have to specify the type of the service that we want to create. Okay, the port on the port where the actual web server is running, it's 8080. We call it target port as this is the target which we want to connect. And this is where all the services forwards the request to. Then we define the port for the service. Since we are creating service objects, we'll simply call the port for service as port. This port will be used by services to communicate within the cluster. And then we have the port on the node, which will be used by end users or external data source to connect externally. And this is known as the node port. As you can see, it is 30007 because like we mentioned, its value range between 30,000 to 32767. If you do not specify the node port, Kubernetes will apply a random available port number. This configuration exposes the application outside the cluster via the node's IP and the specified port. We also have to use a selector to link the service to the relevant ports. So we will use selector and pass the label. Okay, let's open terminal and create a NodePort service. We can create the service using the command kubectl apply -f and the file name, and we can see a service has been created. Now let's use the command kubectl get service or svc to get list of services. Okay, now we can see the name of our service and the type is NodePort. We have an internal IP address, but that is the cluster IP address, and we have to find the node's IP address.
And we can see that a port 30005 has been created that can be used to connect to this service. Okay, in Minikube, we can use the command minikube IP-p and the cluster name, that is Minikube in my case, to get the IP address, and we can use this IP address and the port number 30005 on the browser to check the web application. But if you have a Docker on desktop and using Minikube, you have to use the command minikube service and the service name -p and the cluster name. This will open browser by creating a tunnel on the terminal, and you can see NGINS application is now loaded.
And we can say that we can now connect to our ports inside a cluster using Node IP and port with the help of a NodePort service. Great! Now we understand how communication works within the cluster using cluster IP and how external users can access our ports using NodePort service. But what if we have multiple ports running? Since in production, you often have multiple instances of your application for high availability and load balancing. In this case, all ports with the same label, example app equals to frontend or app equals to backend, are grouped by the service using that label as a selector. When external request comes in, the service identifies the matching ports and evenly distributes the request across them using a random algorithm acting as a built-in load balancer. Now, what happens if these ports are spread across different nodes in the cluster? Without any additional setup, kubectl creates a service that spans across all nodes and maps the same node port to every node. This means you can access the application using any node's IP and the node port. As ports are added or removed, Kubernetes automatically updates the service, making it adaptive and easy to manage without further configuration. But there is a downside. Creating a service of type node port exposes the application on a high-end port of the node. Which IP do you provide to users to access? They can't choose from multiple IPs, right? Instead, they need a single reliable URL. So we need a load balancer. Don't confuse it with load balancing, as load balancing is handled by both the services. This is another type of service called as load balancer service. While setting up a separate load balancer VM and configuring DNS is possible, but it's complex and time consuming. Thankfully, Kubernetes simplifies this by integrating with cloud providers to automate the process. What does that mean? Well, the load balancer service type is ideal for cloud platforms, that is AWS, Azure, and GCP, because it automatically provisions an external load balancer that distributes traffic across the pods. Essentially, it combines the functionality of cluster IP and NodePort while leveraging cloud-based load balancing. So, these public cloud providers like AWS, Azure, and GCP have an inbuilt mechanism for load balancing for Kubernetes. Let's look at the YAML file. So, only thing that changes in the YAML is the type name, and we call it load balancer. When deployed in a cloud environment, this service type provisions an external load balancer to distribute incoming traffic to the appropriate ports through the node's IP address. External users connect via the load balancer's IP, simplifying traffic management. Since we are using Minikube as the cluster provider, we cannot leverage the cloud provider's load balancer. And hence, now when we create a service using command kubectl apply f and the file name, a service will still be created. But when we do kubectl get service, we will get service as name load balancer, and we can see that external IP is pending because Minikube can't provision this. But if we had Kubernetes set up on a cloud provider like Azure, AWS, or GCP, then this IP will be available and we can use it to communicate with our cluster and the services and objects. We can still access it by using command minikube service name -p and the cluster name. And we can see that the NGINS application is loaded on the browser. That's it for the load balancer service. Then we have external name service. The external name service type maps a Kubernetes service to an external DNS name. Instead of exposing a set of ports, it returns an external address. This is useful for integrating known Kubernetes services with a Kubernetes application. So let's look at the YAML file. It will also have the API version kind, and the metadata will provide a name like external name service. And in the spec part, we will have the type as external name And there is another field called as external name where we provide the URL for the external DNS. And how it works: when a request hits this service, it resolves the DNS name to an external IP and routes the traffic there. So your application can interact with non-Kubernetes services transparently. Now let's talk about a very common service which is used in Kubernetes, that is ingress service. An ingress service in Kubernetes allows you to manage external access to the service within the cluster, typically via HTTP and HTTPS routing. Unlike a load balancer service, which directly exposes an IP for each service, Ingress allows multiple services to be exposed through a single external IP with a different URL or URL paths. This is especially useful for web applications where you have multiple endpoints like forward slash login, dashboard, shopping, payment, etc. Imagine you are running a web application with various microservices such as front ends, back ends, and APIs. Without Ingress, each service would need its own load balancer or NodePort, which could lead to inefficiencies, higher cost, and complexity in routing traffic to the right services. Ingress resolves this by using a single point of entry and routing traffic to the appropriate services based on the URL path. However, we will create a separate video on Ingress as it's a complete bigger topic and we will add it to this playlist. That's it for this video on Kubernetes services. We have covered how services help and why they are needed and export different services types. I hope this video helps you master Kubernetes services. Don't forget to like, share and subscribe for more such insights.